Good day. How are you doing today, guys? Kumusta inyong ECQ or enhanced quarantine or enhanced community quarantine? Yeah, for the meantime, since we are not allowed to go outside from our houses, I have decided to make another video, and this is just a basic of what we call sets. So let's start. Based on what you can see on your screen right now, you have a definition of set there. It is a collection of items called elements. These, I can give you examples of what are sets. So let's have example number one. Um, Example, we have sets, members of a set in the English alphabet, small letters A, B, C, and D. So this is an example of a set. And the elements that we are talking about here, this one here, is the item that belongs to that particular set. So this one is the first element, second, third element, and this is fourth element. Okay, so let's have another example. Example sets of numbers 1, 3, 5, 7. This is also another example of a set wherein the elements are the numbers 1, 3, 5, 7. Or you can say odd numbers from 1 to 7. Another example is we can say like this. Sets of fruits that are circular. We can say apple, grapes, and watermelon. Okay. All right, so these three are examples of a set. If you encounter a set like this, meaning there's nothing inside, that's what we called an empty set. Or you can say a null set. Most of the books are using like a notation for null set here. So if you see a notation like this one here, this two brackets without anything inside, or this notation, a circular one with a line across it, that's what we call an empty set. Okay, I hope you are now having a gist of what a set is. We're going to proceed on dealing with examples or how to write a set, or let's say writing a set notation. We have now an idea what a set is. Right now, we're going to talk about how to write a set. And we have two ways to do that. First is the roster method, and second, the set builder notation. What is the difference between these two? So the roster method is actually the listing of all elements in the set. Well, the set builder notation is using a description about the set. Okay, so let's have an example here. Let's say we can say, give me a set, or we have a set. The elements are 2, 4, 6, 8, and 10. This example, the way it is written, is actually we called roster method. Roster method because, technically you are just writing all the elements inside the set. If you wish to convert this into set builder notation, ladies and gentlemen, you would need to have a what? A description about the particular set. You can say set of all x where x is an even number between 0 and 12. That's it. Or you can also say x, set of all x, where x is an even number from 2 to 10. What is the difference between these two? If we're going to study the structure of the statement, when you say between 0 and 12, we're looking at the numbers from 2 to 10, so excluding 0 and 12. If we're going to look at the structure of a statement here from 2 to 10, we're looking at including 2 and including 10. And we're only dealing with the even numbers. So that's the two ways for you to be able to write a set. We discussed earlier how to write a set, either roster method or using the set builder notation. At this moment, we're going to try to verify if a particular element is part of a set or not. So let's say, for example, we have set A, and its elements are 1, 2, 3, 4, and 5. And let's say I have a question for you. Is 6 an element of set A? Your answer is going to be no, and my answer as well. Because obviously speaking, 6 is not part of the elements here. There's no 6 here, right? So basically you can say 6 is not an element of set A. This notation that you can see here represents not an element, or you can say does not belong to. So you can say 6 is not an element of A, or you can say 6 does not belong to set A. Okay? So what if I have another question for you guys? Is 4 an element of set A? The answer this time is going to be a yes. Or you can say 4 is an element of A. So notice the difference here of these two notations. This notation here has a line across it, and this notation here doesn't have a line across it. So this one here actually confirms that a particular element is part of A. However, this one here would tell you that an element is not part of a set. So you know that 4 is part of the set because it clearly shows here that there's 4 in set A. You can say 4 is an element of A, or 4 belongs to set A. We talked about the definition of a set. We also talked about how to write a set. And lastly, we had talked about how to identify if an element is part of a set or not. At this moment, we're going to talk about what's the union and the intersection of two sets. So basically, we're going to deal with two sets here. When we say union of two sets, this actually means the set of elements that belong to set A or set B or both. So the idea of union, guys, I'm sorry for the mispronunciation of the word union. The idea of union, it's actually the combination of all sets inside set A and set B. The intersection part, guys, it's technically the common elements that are in set A and set B. Meaning to say, try to look at what is that element that is present in set A at the same time present in set B. meaning to say the common elements of the two sets. So common elements of the two sets. All right, so let's try to discuss an example. So we have an example. Let me write the example here. Let's say we have a set, what? 1, 2, 3, 4, 5. And we have set B, let's say 2, 6, 10. That's it. All right, so here, if we are going to look at the union of the two sets, if we're going to show that in a Venn diagram, ladies and gentlemen, it should look like this. So you have two sets here, you have two sets here. This is the union part, actually. The union part is the set that belongs to A or B or both. So basically, it's all the elements inside both A and B. If we're going to represent intersection in a Venn diagram, it should look like this. So you have set. Let me just make the circle more clearer for you. There. So this is set A. This is set B. The intersection, guys, is only the elements that are inside this portion here. So technically, common thing of A and B. So if I were to ask you, guys, can you find what is the union of set A and set B? The only thing you're going to do, ladies and gentlemen, is you write all the elements inside A, also in B. So that's going to be 1. Though you notice that there are 2 here, you just have to write them once. So 1, 2, 3, 4, 5, 6, and 10. So this is the union of set A and B. The intersection, by the way, this is the notation for the union. This is it's a long U. That's the notation of union. This is a notation of intersection. So it's a heel-like symbol. So again, as I've mentioned earlier, intersection is what? The common elements or elements from A and also from B. So notice in this example that we have here, the elements that, or rather, the element that is present in set A is 2, and at the same time, it's present in set B. So basically, the intersection is just set the element 2. Okay?